Every rock, mountain and mineral holds a secret, a clue to Earth's 4.5 billion year history. This isn't just science, it's the biography of our world, filled with drama, mystery and wonder. Welcome to 100 fascinating facts about geology, a journey through the forces that built our planet and continue to shape its future. Fact 1. The fiery beginning. How Earth formed from cosmic dust. Imagine floating through a silent sea of dust and gas, with tiny particles swirling around you. That's what our solar system once was, a spinning cloud left over after the birth of the sun. Out of that chaos, the Earth began to take shape. At first, it wasn't the blue world we know. It was a glowing ball of molten rock, hammered again and again by asteroids. Each collision melted the surface, shaping it into a sphere and slowly pulling everything heavier toward the centre. This was no peaceful beginning. Temperatures soared so high that even metals were liquid. Iron and nickel sank inward to form the core, while lighter minerals floated to the surface. The early Earth was alive with fire, volcanoes bursting, lava seas churning, and lightning flashing across a poisonous sky. If you could stand there, you'd see no water, no continents, no life, only a world still deciding what it wanted to be. Over time, as space debris cleared and the bombardment eased, something miraculous began: cooling. The crust thickened, the fiery glow dimmed, and the first solid rocks formed. That slow cooling laid the groundwork for everything that would come. Oceans, mountains, even life itself. From dust to fire to stone. Earth's creation wasn't a single event, but a violent, magnificent transformation that set the stage for every story that followed. Fact 2. The Hadean Eon, our planet's violent youth. If Earth's history were a day, the Hadean Eon would be the wild, sleepless first hours, when everything was chaos. Lasting from about 4.5 to 4 billion years ago, this was a time when the surface of Earth was constantly destroyed and rebuilt. Imagine oceans of magma stretching for miles, continents that cracked before they cooled, and constant impacts from space. Each strike reshaped the planet, sometimes vaporizing entire regions. Yet, even in all that destruction, something remarkable was happening. The crust began to stabilize, and deep beneath it, minerals started forming. Zircon crystals, tiny but nearly indestructible, became the earliest witnesses of Earth's past. Some of them, found in Western Australia, are more than 4 billion years old. They're the closest thing we have to a memory from that time. Scientists call it Hadean, after Hades, the underworld. But it wasn't just fire and ruin. It was the foundation stage, the planet's test run. The molten surface began to cool enough for liquid water to exist in some areas, and that changed everything. Even though no life existed yet, the chemistry that would one day make it possible was quietly forming in the cracks of those newborn rocks. The Hadean Eon was violent, yes, but it was also creative, the moment chaos began turning into order. Fact 3. How Earth got its water. Here's a mystery that still fascinates scientists. How did our blazing, molten Earth end up covered in oceans? The early planet was far too hot for liquid water to exist. Any that tried to form would have boiled away instantly. So, where did all this water come from? One idea says it came from inside. When Earth cooled, volcanic eruptions released gases trapped deep underground, including steam. Over millions of years, that steam condensed into rain, falling again and again until it filled the low places with water. Another idea reaches farther into space. Comets and asteroids carrying ice may have slammed into Earth, delivering their frozen cargo. Maybe it was both. The sky and the rocks working together. Over time, the steam and ice melted into the same story, the birth of the oceans. Once water covered the surface, it became the ultimate sculptor. It cooled the crust, carved the first valleys, and started the endless cycle of erosion and renewal. Without it, there would be no rivers, no atmosphere, and no life. Every drop we drink is ancient, a survivor from the earliest chapters of Earth's tale, recycled through time for billions of years. Fact 4. The oldest rocks ever found. If rocks could speak, What would they tell us about the dawn of time? Deep in places like Greenland, Canada, and Western Australia, scientists have discovered stones that whisper from more than 4 billion years ago. These are not ordinary rocks. They're fragments of the planet's first crust, survivors from the very edge of creation. One of the oldest known formations is the Acasta gneiss in Canada's Northwest Territories, dating back about 4 billion years. Its minerals show that even then, the Earth had cooled enough for solid land and maybe even small seas. Another ancient witness, the Jack Hill zircons of Australia, are tiny crystals older still, around 4.4 billion years. These microscopic gems outlasted entire continents. Every discovery like this reshapes how we see Earth's timeline. They reveal that the crust formed sooner than once thought, and that conditions for water, and possibly life, may have existed much earlier. When geologists hold these stones, they're not just studying minerals, they're touching the remains of a world that no longer exists. Each flake of ancient rock is a fragment of memory, a reminder that beneath our feet lies the record of everything Earth has ever been. Fact 5. The formation of the moon, a giant impact. Look up at the moon tonight, and you're looking at Earth's oldest companion, born out of violence. Around 4.5 billion years ago, a Mars-sized object slammed into our young planet. The collision was so intense that it melted both worlds, throwing vast amounts of molten rock into space. That debris, trapped by Earth's gravity, began to swirl and clump together until it became the moon. For a while, the Earth glowed brighter than ever, and the new moon orbited much closer, so close it would have looked enormous in the sky. The tides it caused were massive, reshaping coastlines and speeding up the evolution of the planet's spin. Over time, the moon drifted farther away, taking on the quiet, familiar face we see now. This impact didn't just create the moon, it changed Earth forever. It tilted our axis, giving us seasons. It stabilized our rotation, preventing wild swings that could have made life impossible. What began as destruction ended up shaping balance. The moon is more than a light in the night sky. It's a piece of Earth itself, a scar that turned into beauty. Fact 6. Earth's first continents, cratons and shields. When the Earth finally cooled enough for solid crust to form, it wasn't smooth and stable like today. The first continents were small, rocky patches, cratons, floating on a sea of molten rock. These cratons slowly merged, cracked apart, and merged again, becoming the building blocks of all continents we know. The Canadian Shield, for example, is one of those ancient survivors. So are parts of Africa, Australia, and Greenland. These places hold the oldest continental rocks, and walking on them is like stepping back in time billions of years. They've endured every upheaval, volcanic eruptions, mountain building, ice ages, and still stand strong. At first, these continents may have been barren, surrounded by steamy oceans under a dim sun. But they became the platforms where the story of life would eventually unfold. They gave Earth structure, places for rivers to flow, minerals to form, and ecosystems to one day begin. In their survival, they show us how the planet learned endurance, how even from fire and fracture something lasting could emerge. Fact 7. The Great Oxygenation. Event. Imagine a world with no breathable air. That was Earth for billions of years. Then something extraordinary happened. Tiny microscopic life forms began releasing oxygen through photosynthesis. It didn't happen overnight. It took millions of years. But slowly, the oxygen built up in the oceans and then spilled into the atmosphere, changing everything. Before this, the planet's air was full of methane and carbon dioxide. When oxygen entered the mix, it reacted with iron in the oceans, forming layers of rusty red sediment, the banded iron formations we still see today. That was the planet's first chemical record of transformation. At first, this oxygen was toxic to most early organisms, and many died off. But for others, it was a new beginning, paving the way for complex life. The sky itself changed colour, and the ozone layer began to form, protecting the surface from harsh solar radiation. The Great Oxygenation event wasn't just a shift in chemistry, it was the moment Earth took its first real breath. Fact 8. Snowball Earth, when the planet froze. Solid. Now picture the entire world wrapped in ice, oceans frozen from pole to pole, sunlight bouncing off a white planet. That's not science fiction. It really happened. Scientists call it Snowball Earth, a period around 700 million years ago when the planet's temperature dropped so drastically that even the equator froze. The cause is still debated. Some think volcanic gases changed the climate. Others blame shifts in sunlight or carbon dioxide. Whatever the reason, life faced its biggest challenge. Beneath the ice, only the hardiest microorganisms survived, clinging to volcanic vents and cracks where warmth remained. But eventually volcanoes released enough carbon dioxide to trap heat again. The ice melted, seas roared back to life, and Earth transformed almost overnight. That dramatic thaw may have triggered an explosion of new species and complexity. It's a stunning reminder of Earth's resilience, frozen nearly solid, yet always finding a way to start again. Fact 9. How volcanoes created the atmosphere. Every breath we take owes something to volcanoes. Long before forests and oceans shaped our air, volcanoes did. In Earth's early days, they erupted endlessly, not just spewing lava but releasing vast clouds of gas, steam, carbon dioxide, sulfur, and traces of nitrogen. Those gases gathered to form the first atmosphere. It wasn't pleasant, thick, hot, and suffocating, but it was a start. Over millions of years, volcanic activity and chemical reactions balanced the gases, and as the planet cooled, water vapor condensed into rain. Oceans formed, absorbing carbon dioxide and leaving behind an atmosphere that slowly became more stable. Even today, volcanoes continue that ancient work, recycling gases between Earth's interior and sky. Without them, there would be no breathable air, no climate, and no weather. Every eruption, no matter how destructive, is part of that deep rhythm, the breathing of the planet itself, still shaping the air above us. Fact 10. The endless cycle, weathering and renewal. If you've ever seen a mountain crumble into sand or a rock split after a storm, you've witnessed one of the Earth's most patient forces, weathering. Rain, wind, ice, and time all work together to break down even the hardest stone. It's a slow, endless process, but without it the planet would never renew itself. Mountains rise through tectonic power, but weathering wears them down grain by grain, sending sediment into rivers and oceans. There it settles and forms new layers of rock, ready to be lifted again someday. This is Earth's cycle of renewal, creation, destruction, rebirth, written across landscapes. Even the soil under your feet is part of this story, made from the remains of ancient rocks. Every pebble, every grain of sand has lived many lives, mountain, riverbed, desert, and back again. The Earth never stands still. It's always in motion, always reshaping itself. And in that quiet persistence, it reminds us of something profound. Even the hardest things can change, given time. Fact 11. The 3 types of rocks. Igneous, sedimentary, metamorphic. Every rock on Earth has a story, and nearly all of them fall into 3 great families: igneous, sedimentary, and metamorphic. Think of them as the planet's storytellers, each one shaped by time, heat, and pressure in its own way. Igneous rocks are born from fire. They come straight from molten magma or lava that cools and hardens, sometimes deep underground, sometimes in a sudden burst at the surface. Sedimentary rocks, on the other hand, are formed in quiet patience. They begin as broken pieces of older rocks, grains of sand, or even shells, settling in layers over ages until pressure turns them into solid stone. And then there are metamorphic rocks, the ones that change. They start as something else entirely, but under heat and pressure, their structure transforms, creating something new. Together, these 3 types form a kind of conversation through time. A volcano erupts, making igneous rock. That rock breaks apart and drifts into rivers, becoming sedimentary. Later, buried deep, it's reborn as metamorphic. The cycle never stops. It's the Earth's way of keeping the story alive. Fact 12. How granite forms. Deep beneath mountains, granite, the speckled, sparkling stone we use for countertops, once lived miles underground, born in slow, fiery stillness. It forms when molten magma cools far below the surface, insulated by rock. Because it cools so slowly, the minerals inside have time to grow into visible crystals, quartz, feldspar, mica, all blending into that familiar textured look. This process happens mostly beneath massive mountain ranges, where magma seeps upward but never quite breaks through. Over millions of years, as the mountains rise and erosion wears them down, the granite hidden inside begins to show. What was once buried under unimaginable pressure eventually becomes the peaks, cliffs, and boulders we see today. Every piece of granite is like a time capsule from deep within the earth. The glittering crystals tell us how long it took to cool, how hot it once was, and what elements were swirling in the molten heart of the planet. It's calm and beautiful now, but its origin story is pure fire. Fact 13. Basalt, the most common rock on Earth. If Earth had a favourite rock, it would be basalt. You'll find it almost everywhere, on the ocean floor, in volcanic islands, and even on the Moon and Mars. It forms when lava flows quickly over the surface and cools before crystals can grow, creating a dark, dense stone. Basalt is what makes up most of the oceanic crust. Every time molten rock rises from the mid-ocean ridges, it spreads outward, hardens, and becomes part of that deep underwater landscape. On land, basalt builds entire regions, like Hawaii's black beaches or the towering cliffs of Iceland. What makes it so fascinating is its simplicity. Basalt doesn't glitter or shine like granite. It's plain, dark, and humble. Yet it's the backbone of our planet's outer shell. Every step across a basalt plain is a step across the planet's most fundamental foundation, the quiet workhorse of geology that supports everything above it. Fact 14. What makes obsidian so sharp? Hold a piece of obsidian, and you're holding nature's glass. Black, smooth, and sharper than any metal blade. Obsidian forms when lava cools so fast that it has no time to crystallize. Instead of forming visible minerals, it hardens into pure volcanic glass. Ancient people discovered how sharp it could be long before modern tools existed. A freshly broken edge of obsidian can slice at a microscopic level, so sharp that even surgeons have experimented with it for precise cuts. Its beauty also made it prized for ornaments and ceremonial objects. Obsidian's perfection comes from chaos. It's the result of lava frozen in an instant. Every piece is unique, often with swirls or ripples showing the motion of the molten rock just before it stopped. It's a reminder that even the most violent forces can create something smooth, elegant, and razor-thin. A frozen moment of volcanic fury turned into art. Fact 15. The hidden story. Inside, sedimentary layers. Walk by a cliff or canyon wall and you're looking at the Earth's diary. Each band of sediment tells a story of rivers flowing, winds blowing, or seas rising and falling long ago. These are sedimentary layers, and reading them is like turning the pages of time itself. The bottom layers are the oldest, formed from mud, sand, or tiny shells that settled in calm waters. Over millions of years, more layers built up, compressing the ones beneath. Sometimes fossils get trapped between them, freezing moments of life forever in stone. Other layers show ripples from ancient tides or ash from a faraway eruption. Geologists can tell where deserts once stood, where rivers once ran, and how climates changed, all by studying these thin lines of rock. The beauty of sedimentary layers is in their patience. They don't shout, they whisper, and if you listen closely you can almost hear the echoes of vanished worlds layered beneath your feet. Fact 16. Metamorphism. Rocks reborn under pressure. Metamorphism is what happens when rocks go through a second life. Picture a stone buried deep within the earth, squeezed and heated for millions of years until its minerals rearrange. It doesn't melt, it transforms. That's how we get marble from limestone or schist from shale. Old rocks reborn with new textures and sparkle. Deep beneath mountain ranges, pressure and heat rise together, forcing change. The atoms inside the rock move, realign, and sometimes grow into new crystals. You can even see the layers twist and shimmer, like the rock itself remembers the strain it endured. Metamorphic rocks are nature's survivors. They've lived through unimaginable pressure and come out stronger. Each one carries the scars and beauty of its transformation, proof that even stone can evolve when the world around it becomes too intense to stay the same. Fact 17. The rock cycle explained. The rock cycle is Earth's version of reincarnation, an endless loop where no rock stays the same forever. Imagine a piece of granite on a mountain peak. Over time, wind and rain wear it down, and fragments wash into a river. Those pieces settle in a lake and turn into sedimentary rock. Later, deep inside the planet, heat and pressure change it again. Now it's metamorphic. Eventually it melts, rises as magma, and cools into new igneous rock. And the cycle begins again. This process takes millions, sometimes billions, of years, but it never stops. The surface changes, continents move, volcanoes erupt, all feeding this quiet rhythm. The rock cycle shows that nothing on Earth is truly permanent. Everything transforms given enough time. Even the hardest mountain eventually becomes sand. It's a humbling reminder that change isn't the exception, it's the rule. Fact 18. Diamonds, born from deep Earth's heat. A diamond's sparkle begins in darkness. Far beneath the surface, more than 100 miles down, carbon atoms are squeezed under extreme heat and pressure until they lock into a crystal lattice, the hardest natural material known. For millions of years, these crystals remain hidden, until a volcanic eruption blasts them toward the surface, inside chunks of ancient magma called kimberlite. Each diamond tells a story of impossible endurance. Most are over 1 billion years old, formed before the continents even looked as they do today. Their clarity and brilliance come not from gentleness, but from the relentless pressure that created them. When people hold a diamond, they see beauty, but inside it lies a record of Earth's deepest power. It's more than a gemstone. It's a message from the mantle, proof that even under the most crushing forces, something extraordinary can form. Fact 19. Quartz. The most abundant mineral on the surface. Look around. Quartz is everywhere. From beach sand to mountain peaks, this crystal makes up a huge part of the planet's crust. It forms when silicon and oxygen, two of the most common elements on Earth, join together under the right conditions. The result is a mineral that's clear, strong, and incredibly resistant to weathering. Quartz comes in many forms: amethyst's purple glow, smoky quartz's soft haze, or the simple sparkle of pure crystal. It can be found in igneous, metamorphic, and sedimentary rocks, showing up wherever Earth builds or breaks things apart. Because quartz resists erosion so well, it ends up as the last survivor, what most sand beaches are made of. So the next time you walk barefoot on the shore, you're really walking on crushed quartz, shaped by countless tides and centuries. It's the quiet backbone of the landscape, simple, common, and timeless. Fact 20. Fool's gold, the science of pyrite. It glitters like treasure but deceives the hopeful eye. Pyrite, better known as fool's gold. Early prospectors often mistook it for real gold because of its metallic shine and yellow colour. But unlike gold, pyrite is brittle and formed from iron and sulphur, not precious metal. Still, pyrite is far from worthless. It forms beautiful cubes and patterns, and in some cases, it's a clue to the presence of real gold nearby. Pyrite also plays a key role in geology, helping scientists understand the conditions of ancient environments. Its presence in certain rocks tells whether they formed in oxygen-poor or oxygen-rich settings. Even its name, from the Greek word for fire, comes from its ability to spark when struck against steel. Fool's gold might trick the eye, but it never hides its true nature for long. It's a reminder that not everything valuable shines in the same way. Sometimes beauty lies in the lesson it teaches. Fact 21. How crystals grow in nature. Ever noticed how snowflakes, salt and quartz all share something magical? Their symmetry. Crystals are nature's architects, and they grow with patience that spans ages. Picture a pocket of molten rock cooling slowly beneath the Earth's crust. As it cools, atoms begin to arrange themselves into repeating patterns, forming the geometric beauty we call crystals. But not all crystals grow underground. Some form in watery environments, inside caves for instance, where dripping mineral-rich water leaves tiny deposits behind. Over centuries those deposits grow into stunning stalactites lined with glimmering calcite. Others, like salt crystals, can appear in something as simple as a drying pond, where evaporation leaves behind glistening cubic shapes. Crystals form under precise conditions, the right temperature, pressure, and chemical ingredients. Change one, and you'll get a completely different mineral. That's why no two environments produce the same crystal twins. It's also why gemstones like amethyst and citrine, though chemically similar, have such distinct colours. It's all about trace elements and temperature. Some crystals, like diamonds, take shape deep in the mantle, under immense heat and pressure. Others, like gypsum, form just beneath the surface in cool, calm conditions. Together, they show that beauty in nature can come from extremes, fire or tranquility. And perhaps that's what's so fascinating. Every crystal is a record of its environment. When geologists hold one up to the light, they're not just admiring sparkle. They're reading a history book written in atoms. Fact 22. The rarest mineral on Earth. You might think gold or diamonds are rare, but compared to a mineral called kyorthouite, they're as common as pebbles. Only one confirmed specimen of kyorthouite exists, smaller than a grain of rice. Found in Myanmar, this reddish-brown crystal is so rare that it's technically one of a kind. What makes a mineral rare isn't always how valuable it is. It's how unique the conditions must be for it to form. Some require such specific temperatures, pressures, or chemical mixes that they've only appeared once in known history. Kyorthouite, for example, was likely born in the intense geological collision zones deep within the Earth under conditions nearly impossible to reproduce. Then there's painite, another contender once thought to be the rarest. Discovered in the 1950s, for decades only 3 crystals were known. It wasn't until the 2000s that more were found. Even so, it's still rarer than most gems on Earth. Rarity in geology reminds us that Earth is still full of mysteries. With every new discovery, scientists realize how little of the planet's deep secrets we've uncovered. Somewhere beneath our feet, perhaps miles underground, there could be other minerals that exist in conditions we've never seen. That's the beauty of geology. Even after centuries of study, it keeps surprising us. One grain of crystal can rewrite what we thought we knew about the planet's chemistry. Fact 23. Gemstones and their geological origins. Every gemstone carries a story of fire, pressure, and time. They're not just beautiful, they're survivors. Take sapphire, for instance. It forms deep underground from aluminum oxide under crushing heat. Swap in a little chromium, and suddenly it's ruby. The same mineral, different colour, all thanks to trace elements. Emeralds, on the other hand, come from a completely different process. They grow when mineral-rich fluids seep into cracks in rocks, cooling slowly to form green crystals of beryl. That's why emeralds often have tiny fractures inside. They're geological fingerprints of how they formed. Opals form in a gentler setting, silica-rich water filling cavities in rocks. Over time, as the water evaporates, the silica settles into layers that bend light into dazzling colours. No two opals ever look alike, and that's part of their magic. What's remarkable is how global these processes are. Rubies from Myanmar, emeralds from Colombia, sapphires from Madagascar, all shaped by unique geological environments that took millions of years to perfect. When you wear a gemstone, you're carrying a piece of the planet's deep history. Every sparkle is a fragment of pressure, heat, and time, a geological story written in colour. Fact 24. What makes opals iridescent? Hold an opal to the light, and you'll see a rainbow shift across its surface. Red, green, blue, all dancing as you move it. That shimmer isn't from pigment or dye, it's from structure. Opals are made of countless microscopic spheres of silica arranged in a tight pattern. When light enters, it bends and splits, creating interference, the same effect you see on soap bubbles or oil slicks. The size and arrangement of those spheres decide which colours you see. Larger spheres produce reds and oranges, smaller ones blues and greens. That's why no two opals are identical. Each one has its own pattern, its own light show. Most opals form when water carrying dissolved silica fills cracks in rock, then evaporates over thousands of years. What's left behind is that delicate, ordered structure that scatters light so beautifully. Opals are fragile too. They can dry out or crack if not cared for. Yet maybe that fragility adds to their allure. They're reminders that beauty often forms in balance, between water and stone, light and structure, chance and time. Fact 25. Salt domes and the geology of salt might seem ordinary, but it has a secret life underground. Beneath places like Texas, Iran and Germany lie enormous salt formations, miles wide, rising like slow-motion mountains from deep below. These are salt domes, created when thick layers of salt buried under heavier rock begin to flow upward. You wouldn't think salt could flow, but under pressure, over millions of years, it behaves almost like a thick liquid. As it pushes upward, it bends and fractures the rock above, sometimes trapping oil and gas inside. That's why salt domes became crucial in energy exploration. They're natural storage vaults created by geology itself. Salt also tells the story of vanished seas. Most large deposits began as ancient oceans that evaporated, leaving behind thick beds of halite. Layer upon layer of salt recorded the drying of entire seas. And here's the twist. Some salt domes reach so high they deform the landscape above them, creating hills in otherwise flat terrain. So next time you see a subtle rise in a salt basin, you might just be standing above a massive, slow-moving tower of salt, still pushing its way toward the surface. Fact 26. Meteorites. Rocks from outer space. Imagine holding a rock that's older than Earth itself. That's what meteorites are. Fragments from the early solar system that survived a fiery plunge through our atmosphere. Most meteorites come from asteroids, some from the Moon or Mars. They've been drifting for billions of years before crashing here. Each one tells a story about how planets formed, what materials existed before Earth even began. There are three main types: stony, iron, and stony iron. Stony ones are the most common, resembling dense, dark rocks. Iron meteorites, though, are spectacular. Heavy, metallic, and often etched with unique patterns formed by slow cooling in space. When geologists slice a meteorite, they're peering back to the dawn of the solar system. The isotopes inside reveal how the planets differentiated, how metal sank to form cores and rock floated to create crusts. Meteorites remind us that geology doesn't stop at Earth's edge. Our planet's story began in space, and these space rocks are the surviving witnesses. Fact 27. Radioactive minerals and the age of the Earth. How old is our planet? The answer lies in a few glowing minerals deep underground. Radioactive elements like uranium, thorium, and potassium decay at fixed rates, turning into stable daughter elements. By measuring how much has decayed, scientists can calculate the age of the rock, and by extension, the Earth. This method, called radiometric dating, was revolutionary. It proved that Earth wasn't a few thousand years old, but over 4.5 billion. Some minerals, like zircon, are perfect timekeepers. They resist weathering, so even after the rock around them erodes, zircons survive, holding isotopic clues to the earliest days of the planet. Through them, geologists have glimpsed the Hadean world, when molten crust solidified, water condensed, and continents began to take shape. In a sense, radioactive minerals are the planet's clocks. They tick silently beneath our feet, keeping time not in seconds but in eons. Fact 28. How geologists identify minerals. Imagine being able to read rocks like words. That's what geologists do. To identify a mineral, they rely on clues hidden in colour, luster, hardness, and shape. They might start with a simple scratch test. Can it scratch glass? Then it's harder than quartz. Does it fizz when touched with acid? That could mean it's calcite. Even the way a mineral breaks, smooth or jagged, tells a story about its structure. Light is another clue. Some minerals glow under ultraviolet light, while others show a streak of colour when rubbed on porcelain. And sometimes, a microscope reveals crystal patterns invisible to the naked eye. Geometric perfection formed over ages. Field geologists often carry a small kit: a hand lens, knife, magnet, and acid dropper. With just these, they can identify most minerals on the spot. It's a skill that takes years to master. learning to see not just what's visible, but what the rock is saying through texture, colour, and feel. Fact 29. Birth of precious metals. Gold and silver. Gold and silver may gleam with luxury, but their birthplaces are among the harshest environments on Earth. These metals form deep underground, where superheated fluids circulate through cracks in rocks. As the fluid cools, it leaves behind fine veins of metal, invisible at first, then rich enough to mine millions of years later. Volcanic regions are especially fertile grounds for these processes. In some cases, gold is even linked to ancient hydrothermal vents, those deep-sea openings where mineral-rich water gushes from the crust. But precious metals also tell a cosmic story. Some of Earth's gold and platinum were delivered by meteorites after the planet's core had already formed. Without those ancient impacts, our crust might be almost barren of these metals. So next time you see a gold ring or silver necklace, remember, it's the product of pressure, fire, and even cosmic collisions. A reminder that beauty often begins in the most violent places imaginable. Fact 30. The story of coal and oil formation. Long before humans, vast swamps covered parts of the Earth. Towering plants grew thick, then fell and decayed, layer after layer. Over millions of years, buried under sediments and pressed by heat and time, that ancient vegetation transformed into coal. Coal is basically concentrated sunlight, the stored energy of prehistoric forests. Oil formed differently. Tiny marine organisms settled on seafloors, buried beneath mud and sand. As pressure rose, their remains turned into liquid hydrocarbons, petroleum. Both are stories of transformation, turning life into energy. They're also reminders of the Earth's slow but powerful cycles. What once grew in sunlight now fuels cities and machines, and yet every piece of coal or drop of oil is a whisper from an ancient world. A world of fern forests, shallow seas, and the long patience of time. Fact 31. Inside a volcano. Magma chambers. Explained deep beneath every volcano lies a restless heart. A magma chamber. It's not a vast open cavern of glowing lava like you might imagine, but more like a dense pressurized sponge of molten rock mixed with crystals and gas. Magma chambers form when molten rock rises from the mantle and gets trapped within the crust. Over time, as more magma pushes upward, pressure builds. If that pressure finds a weakness, a crack, a vent, a fault, it can erupt in a spectacular show of nature's power. But not all chambers erupt. Some slowly cool underground, solidifying into huge bodies of igneous rock called plutons. Mountains like the Sierra Nevada were born from such ancient frozen magma chambers. Geologists study seismic waves and ground deformation to detect these hidden chambers today. It's like listening to Earth's heartbeat. The slightest bulge or tremor can hint that magma is moving. A quiet warning of what's happening below. In a way, magma chambers are nature's pressure cookers. Powerful, unpredictable, and essential for shaping the world we live on. Every eruption, every mountain, every new rock begins here, in Earth's molten core of creativity. Fact 32. The Ring of Fire. Earth's most active zone. Stretching around the edge of the Pacific Ocean is one of the most dramatic regions on Earth, the Ring of Fire. It's not a single place, but a horseshoe-shaped belt where most of the planet's earthquakes and volcanoes occur. Here, giant tectonic plates collide, dive, and grind past one another. When one plate slips beneath another, a process called subduction, heat and pressure melt the descending rock, creating magma that rises to the surface. That's why countries like Japan, Indonesia, Chile, and New Zealand are dotted with volcanoes. Around 75% of the world's active volcanoes are found along this ring. But it's not just about eruptions. The Ring of Fire is where continents are reshaped, mountains rise, islands form, and coastlines shift. It's Earth in motion, alive and restless. Living here comes with risk, but also reward. The same forces that cause quakes and eruptions also create rich soils, fertile land, and geothermal energy. It's a reminder that destruction and creation often come from the same fiery source. Fact 33. How lava turns to rock. When lava erupts onto the surface, it's the end of a long journey, molten rock that began deep underground. But once it spills out, the clock starts ticking. Every second is cooling, hardening, changing. The speed of that cooling decides what kind of rock forms. Slow cooling allows large crystals to grow, creating rocks like basalt. But when lava cools quickly, like in an ocean eruption, it can turn into volcanic glass, known as obsidian. Sometimes, lava cools so fast that gas bubbles get trapped inside, forming pumice, a rock light enough to float. Other times, thick, slow-moving lava piles into ridges and domes that stand for ages. Each lava flow is a frozen moment in time. You can trace the story of an eruption through its layers, how fast it flowed, how hot it was, even how much gas it carried. So next time you see hardened lava, remember, it's more than a rock. It's a moment when fire met air and became stone, a geological transformation you can hold in your hand. Fact 34. Supervolcanoes and global extinctions. A normal volcanic eruption can devastate a region, but a supervolcano changes the entire planet. These rare giants release thousands of times more material than typical eruptions, blanketing continents in ash and altering climate worldwide. The most famous examples are Yellowstone in the United States, Toba in Indonesia, and Taupo in New Zealand. When Toba erupted about 74,000 years ago, it spewed so much ash into the atmosphere that global temperatures dropped for years. A volcanic winter. Supervolcanoes form when massive magma chambers build up immense pressure. Instead of a mountain exploding upward, the ground collapses inward, forming vast depressions called calderas. Their effects go beyond local destruction. Sunlight dims, crops fail, and ecosystems collapse, reminders of how interconnected life is with the planet's deep forces. Thankfully, such eruptions are extremely rare, separated by hundreds of thousands of years. Still, studying them helps scientists understand not just Earth's dangers, but its ability to recover and renew after even the most cataclysmic events. Fact 35. The eruption that changed history, Mount Tambora. In the year 1815, on the island of Sumbawa in Indonesia, the sky turned black for days. Mount Tambora had erupted, the most powerful volcanic explosion in recorded history. The blast was so massive, it destroyed the mountain's top and killed tens of thousands nearby. But its impact reached far beyond Indonesia. Ash from Tambora spread across the globe, blocking sunlight and cooling the planet. The following year became known as the year without a summer. Crops failed in Europe and North America, leading to famine and unrest. Even the sky's strange red sunsets inspired eerie art and literature of the time. Tambora reminds us how deeply the Earth's forces can influence human life. A single eruption reshaped weather, culture, and even history. Today, the mountain stands quiet, its caldera vast and silent. But its story remains a symbol of how one moment of geological fury can echo across centuries. Fact 36. Underwater volcanoes and new land formation. Far below the ocean's surface, volcanoes are constantly at work. In fact, most volcanic activity on Earth happens underwater, along mid-ocean ridges where tectonic plates pull apart. Here, molten rock rises to fill the gaps, forming new crust, literally creating new land under the sea. When these eruptions are strong enough, the lava can pile up until it breaks the surface, forming islands like Iceland or Hawaii. Underwater eruptions look nothing like those on land. The pressure is immense, and the water cools lava so quickly that it solidifies into strange rounded shapes called pillow lavas. These submarine volcanoes are crucial to the planet's renewal cycle. They recycle material from deep inside Earth and create the ocean floors we walk upon, or rather, sail over. So even in the silent dark of the sea, Earth is building, reshaping, and breathing, one bubble of magma at a time. Fact 37. How geysers work. Geysers are like Earth's natural fountains, bursts of boiling water and steam that shoot dramatically into the air. But how do they work? Deep underground, rainwater seeps down until it touches hot rock near a magma source. The water heats up, but because it's trapped by pressure, it doesn't boil, not yet. Then, as more heat builds, bubbles of steam suddenly expand, forcing the water above them upward. That sudden release sends scalding water flying skyward, creating a geyser eruption. Old Faithful in Yellowstone is one of the most famous. Its regular eruptions come from a perfectly balanced underground system of heat, water, and pressure. Geysers are rare. Only a few dozen active ones exist worldwide, because their plumbing systems are fragile. A small earthquake or mineral clog can change them forever. They're a reminder of how delicate yet powerful Earth's natural systems can be. Simple water transformed by hidden fire. Fact 38. Volcanic glass and ash. Tiny geological clues. After an eruption, the air fills with ash and shards so small they seem harmless, but they tell a deep story. Volcanic ash isn't like fireplace ash. It's made of tiny fragments of glass, rock, and crystals formed when magma explodes into the air and cools instantly. These particles can travel thousands of kilometers, settling as thin layers across continents. Geologists study those layers to date eruptions and track past climate changes. Each ash deposit is a timestamp in the Earth's history. Volcanic glass, like obsidian, is another product of rapid cooling. Its smooth, shiny surface hides a violent origin, molten rock that froze before it could crystallize. Even the smallest ash grain or glass flake can reveal how explosive an eruption was, what gases were released, and how fast the magma cooled. Tiny clues, but together they paint a vivid picture of fiery pasts. Fact 39. The deadliest volcanoes ever recorded. Volcanoes can create new worlds, but they can also bring tragedy. Some eruptions have rewritten history with their sheer power. Mount Vesuvius in 79 AD buried Pompeii under ash, preserving it for centuries. Krakatoa in 1883 exploded with a force heard across oceans, sending tsunamis racing toward distant shores. Mount Pelée in 1900 killed thousands within minutes, when a cloud of hot gas and ash, a pyroclastic flow, swept down its slopes. And Mount Tambora, as we've seen, changed global climate for years. These disasters remind us that volcanoes are both creators and destroyers. They shape continents and enrich soils but demand respect from those who live near them. Modern technology helps monitor activity. Satellites, sensors, gas detectors. But nature always has the final word. When a volcano decides to wake, humanity can only watch and adapt. Fact 40. Life, thriving on volcanic islands. You'd think a fresh volcanic island, barren rock, no soil, no shade, would be lifeless. Yet life finds a way. Within years of an eruption, wind and waves bring seeds, spores, and insects. Birds arrive, leaving droppings that nourish the first plants. Mosses and lichens cling to rock, breaking it down into soil. Slowly, an entire ecosystem begins. This process, called ecological succession, has been seen in places like Surtsey, an island born from a 1963 eruption off Iceland. Scientists studied it from the start, watching nature rebuild from zero. Volcanic soil, once established, becomes incredibly fertile. That's why some of the world's luscious landscapes, Hawaii, Java, Sicily, owe their richness to ancient eruptions. Volcanoes may destroy, but they also give birth to new life. They remind us that endings and beginnings often share the same spark, fire that clears the way for renewal. Fact 41. How Alfred Wegener discovered continental drift. In the early 1900s, a German scientist named Alfred Wegener looked at a world map and noticed something strange. The continents seemed to fit together like puzzle pieces. Africa and South America in particular looked as if they had once been connected. At first, it was just an observation, but Wegener couldn't let it go. He began collecting evidence, matching fossils found on different continents, similar rock formations separated by oceans, even ancient climate patterns that didn't make sense unless the continents had once been joined. He proposed a bold idea. The continents weren't fixed. They drifted slowly across the planet's surface over millions of years. He called it continental drift. When Wegener presented his theory, most scientists dismissed it. The idea seemed impossible. How could solid land move? But Wegener held firm, confident that the Earth's surface was not static. He never lived to see his theory proven right. That came decades later, when new discoveries about seafloor spreading and plate tectonics confirmed what he had suspected all along. Today, Wegener is remembered not as a dreamer, but as the man who first glimpsed the moving heartbeat of our planet. Fact 42. The evidence from fossils and rocks. The idea that continents once connected isn't just imagination, it's written in stone and bone. Fossils of identical species like the ancient reptile Mesosaurus have been found in both South America and Africa, separated by thousands of kilometers of ocean. Plants tell the same story. Fossils of the fern Glossopteris appear across multiple southern continents, suggesting they were once joined in a massive supercontinent, Gondwana. Even rocks themselves whisper the same truth. Mountain ranges in North America match those in Scotland, and geological layers on opposite sides of the Atlantic align perfectly, as if torn apart. These clues build a case that can't be ignored. The continents didn't just drift, they carried with them the fossils, rocks, and histories that once lived side by side. Every fossil bed and rock outcrop is a fragment of that ancient connection, proof that the world we know today was once united, then slowly pulled apart by forces deep below. Fact 43. The mid-ocean ridge, Earth's longest mountain range. Hidden beneath the oceans lies the longest mountain range on Earth, the mid-ocean ridge. It stretches for more than 60,000 kilometers, winding around the globe like a scar left by creation itself. At these ridges, tectonic plates are moving apart. Magma rises from below, hardens and forms new crust, pushing the old crust outward. It's where the seafloor is constantly being born. If you could travel along the ridge, you'd see underwater volcanoes, towering cliffs, and hydrothermal vents spewing mineral-rich water. These vents even support strange ecosystems, creatures that live without sunlight, feeding instead on the chemicals from Earth's depths. The mid-ocean ridge is proof that our planet is alive, still creating itself. The continents drift apart, but new land is always forming, a balance of destruction and renewal that never ends. Fact 44. Subduction zones, where crust is recycled. While new crust forms at mid-ocean ridges somewhere else, old crust must disappear, and that happens at subduction zones. Here, one tectonic plate slides beneath another and sinks into the mantle. It's a slow, grinding process that recycles the planet's outer shell. As the descending plate melts, it fuels volcanic activity and reshapes entire regions. The Pacific Ring of Fire is full of these zones, places where immense pressure creates both mountains and earthquakes. Subduction isn't just destruction, it keeps Earth's surface in balance. Without it, the crust would grow endlessly thicker. Instead, the planet maintains a cycle, creation at ridges, renewal through subduction. It's a reminder that even solid rock lives in a constant rhythm, forever changing, forever moving. Fact 45. Earthquakes. When the plates clash. The ground beneath your feet might seem steady, but it's constantly moving, slowly, invisibly. When two tectonic plates grind against each other, strain builds up until the rocks suddenly snap. That's an earthquake. The energy release travels through the earth as seismic waves, shaking everything above. The more strain that builds before release, the stronger the quake. Some quakes last only seconds, others rumble for minutes. Aftershocks can continue for days. And though modern technology can't yet predict them precisely, scientists can monitor fault zones and understand their behavior. Each earthquake reshapes the land, raising mountains, shifting rivers, or even moving entire cities by centimeters. They remind us that the Earth, for all its age and power, is never truly still. Fact 46. Fault lines and crustal stress. Imagine Earth's crust as a massive jigsaw puzzle. Its edges under tension, compression, and friction. Where these forces meet, we get faults, fractures where rocks move past each other. There are three main kinds. Normal faults form when the crust stretches apart. Reverse faults happen when it's compressed. Strike-slip faults occur when plates slide sideways. Each fault stores energy like a loaded spring. When that energy releases, the ground shifts, sometimes gently, sometimes violently. Over time, These movements carve valleys, lift ridges, and shape entire landscapes. Faults are scars, but they're also creative lines, evidence of the planet's restless artistry. They're the reminders etched into stone that the Earth's surface is always in motion, even when it feels calm above. Fact 47. The San Andreas Fault Story. Running through California is one of the world's most famous fault lines, the San Andreas Fault. It marks the boundary between the Pacific Plate and the North American Plate, and it's been shaping the landscape for millions of years. The two plates move past each other at a rate of a few centimeters per year, about as fast as your fingernails grow. But that slow grind builds enormous tension, released in occasional powerful earthquakes. The fault stretches more than 1,000 kilometers, from the Salton Sea up past San Francisco. Along its length, towns, roads, and rivers have all shifted, the land itself torn and reshaped by invisible hands. Scientists have studied the San Andreas for decades, mapping every tremor and movement. It's both a warning and a wonder, a line that tells the story of Earth's ceaseless motion beneath one of its busiest regions. Fact 48. How continents move every year. It's hard to believe, but the continents are on the move right now. Every year they shift a few centimeters, about the same speed your nails grow. This motion happens because tectonic plates float atop the mantle, a semi-fluid layer of hot rock slowly flowing beneath them. Convection currents deep within the Earth push and pull the plates in constant gradual motion. Using satellites and GPS, scientists can now measure these movements precisely. Australia is drifting north, Africa is slowly splitting apart, and the Atlantic Ocean is widening every year. It's subtle, almost invisible on a human timescale, but over millions of years these tiny shifts rearrange the entire face of the planet. Mountains rise, oceans widen, and continents reunite, all because Earth never stops moving. Fact 49. What the future supercontinent might look like. If the continents are always moving, where are they headed? Scientists have tried to predict the next great supercontinent, and it's a fascinating puzzle. Some believe the continents will merge into a supercontinent called Pangaea Proxima, forming around the equator in about 200 million years. Others suggest a major, where the Americas and Asia collide near the Arctic. No one knows for sure, but simulations show that ocean basins will close, mountain ranges will rise, and coastlines will vanish. It's strange to imagine. Cities buried, new deserts forming, and entirely new ecosystems evolving on future shores. Yet that's the cycle of the planet. Drifting, colliding, reforming. We may not see it happen, but the blueprint for Earth's future is already in motion beneath our feet. Fact 50. Earth's magnetic field and continental motion. Every rock carries a tiny compass inside it. When molten rock cools, the iron minerals within align with the Earth's magnetic field, freezing a record of its direction at that moment. By studying these magnetic signatures in ancient rocks, scientists discovered something astonishing. Continents had changed position over time. The magnetic poles seemed to wander, but it was actually the land that moved. This magnetic evidence became one of the strongest proofs for plate tectonics. Even better, it showed how the magnetic field itself has flipped many times throughout history, north becoming south and back again. Earth's magnetic field protects the planet from solar radiation, but it also serves as a silent storyteller. In its invisible patterns, it keeps a record of how continents have drifted, collided, and reshaped the face of the planet over billions of years. Fact 51. How mountains form. From folding to uplift mountains are Earth's grandest sculptures, but they don't rise overnight. They're born from the planet's restless crust, pushed, folded, and lifted by the slow grind of tectonic plates. When two plates collide, immense pressure crumples the rocks like fabric. Layers of sediment once buried deep below rise toward the sky, forming fold mountains such as the Alps or the Appalachians. Other ranges form differently. When blocks of crust crack and tilt, fault block mountains appear, steep on one side, sloping on the other. Volcanic mountains, meanwhile, grow from eruptions that pile lava higher and higher. Each type tells a different story of stress and motion. But all mountains share one truth. They're records of collision and uplift, monuments to the power hidden within our planet's slow heartbeat. Fact 52. The Himalayas, the roof of the world. The Himalayas are still rising. Born 50 million years ago when India crashed into Asia, they continue to grow by a few millimetres each year. This colossal collision forced rock upward, creating the highest peaks on Earth, including Mount Everest, towering more than 8 kilometres above sea level. Yet beneath their frozen summits lies a zone of immense pressure, where the crust thickens and folds like clay. The Himalayas shape the climate of an entire continent, blocking cold winds from the north and feeding rivers that sustain billions of lives. But they're also fragile. Erosion, earthquakes and landslides constantly reshape their slopes. The roof of the world is never still. It's alive, moving and changing with every breath of the earth below. Fact 53. Erosion, nature's sculptor. If mountains are Earth's builders, erosion is its sculptor. Wind, rain, rivers and ice work endlessly, wearing down the highest peaks and carrying their dust to the sea. Tiny grains of sand can grind solid rock over time. Streams carve valleys, and glaciers scrape entire ranges into new shapes. Even chemical reactions dissolve rock, leaving new textures and landscapes behind. It's a slow artistry, measured not in years, but in eons. Every canyon, cliff and river delta you see is the result of erosion's patient hand. Without it, the Earth would be rough and jagged. With it, the planet becomes a gallery of flowing lines and balanced forms, a masterpiece carved by time itself. Fact 54. How rivers carve canyons. A river begins as a trickle, but given time, it can slice through mountains. As water flows downhill, it picks up sediment, tiny pieces of rock that act like blades, grinding deeper into the bedrock below. Over millions of years, this steady erosion creates valleys, and in extreme cases, vast canyons like the Grand Canyon. Each layer of rock exposed on its walls tells a story of ancient seas, deserts and forests long vanished. Floods speed up the process, cutting new channels and widening the gorge. Meanwhile, gravity and weather cause rockfalls that shape the canyon's steep sides. What begins as a river becomes a living timeline, a cross-section through the history of Earth written one layer at a time. Fact 55. The making of deserts and dunes. Deserts aren't just empty spaces, they're living geological systems shaped by wind, heat, and time. They form where air is dry and rainfall rare, often in the shadow of mountains or near the edges of high-pressure zones. Without moisture, rocks crack and crumble under the sun, creating dust and sand that the wind sculpts into dunes. These dunes move like waves, shifting across the land with every gust. Some are tiny ripples, others rise hundreds of meters tall. Even in this apparent stillness, deserts change constantly. Each grain of sand tells of a journey, blown by wind, dropped by storms, or carried from distant mountains long gone. Fact 56. Glaciers, ice that moves, mountains. A glacier is a river of ice, flowing so slowly it seems motionless, yet it reshapes continents. Formed when snow piles up faster than it melts, the weight compresses lower layers into ice. Under pressure, that ice begins to creep downhill, grinding rock beneath it like sandpaper. As glaciers advance, they carve valleys, scoop out lakes, and transport huge boulders for kilometers. When they melt, they leave behind U-shaped valleys, moraines, and plains of glacial debris. Even though many glaciers are retreating today, their marks remain. The world's great landscapes, from the Alps to the Rockies, bear the signature of these frozen sculptors. Fact 57. Karst landscapes and hidden caves. Beneath certain parts of the world lies a secret realm, a landscape carved not by wind or ice, but by water-dissolving stone. When rainwater mixes with carbon dioxide, it forms a weak acid that slowly eats away at limestone and dolomite. Over thousands of years, it creates sinkholes, underground rivers, and vast cave systems. These are called karst landscapes, found in places like southern China, the Balkans, and Kentucky. They're fragile ecosystems shaped by the quiet chemistry of water. Inside their caves, stalactites and stalagmites grow like slow-motion sculptures. Drop by drop, over ages too long for us to truly grasp. Fact 58. Sinkholes and collapsing Earth. Sometimes, the underground voids in karst landscapes collapse suddenly, forming sinkholes. They can appear overnight, swallowing roads or buildings, but the process takes centuries to prepare. As water dissolves the bedrock, empty spaces grow beneath the surface until the ground above can no longer support its own weight. Sinkholes vary in size, from a few meters wide to massive craters hundreds of meters across. While dramatic, they're a natural part of how limestone regions evolve. They remind us that the Earth's surface is only skin deep, and that vast, hidden worlds are always working just below our feet. Fact 59. Coastal cliffs and sea stacks. Where land meets the sea, geology meets its most relentless artist, the ocean. Waves pound cliffs day and night, eroding them piece by piece. Over time, soft rock gives way, leaving behind arches and isolated towers known as sea stacks. Each storm reshapes the coastline a little more, breaking rock, shifting sand, and carrying fragments far away. Some sea stacks, like the 12 Apostles of Australia, stand as temporary monuments, reminders that even the hardest stone yields to the persistence of water. Coasts are never permanent. They're constantly rewritten by the tides. Fact 60. The deepest points on Earth. Far below the ocean's surface lie places so deep that sunlight never reaches them. The planet's true abysses. The deepest known point is the Challenger deep in the Mariana Trench, nearly 11 kilometers beneath the Pacific. The pressure there is over 1,000 times that at sea level. Few creatures can survive such conditions, yet life exists even here. Strange microbes and fish adapted to eternal darkness. These trenches form where one tectonic plate slides beneath another, pulling the seafloor down into the mantle. They're gateways to the planet's hidden depths, reminders of how much of Earth remains unexplored. Fact 61. The Great Barrier Reef. A living geological structure. Stretching for over 2,000 kilometres along Australia's northeastern coast, the Great Barrier Reef isn't just a biological wonder, it's also one of Earth's most extraordinary geological formations. Beneath the dazzling corals and turquoise waters lies a structure millions of years in the making, shaped by both life and stone. The story begins about 20 million years ago, when the Australian continent drifted northward into tropical waters. Coral polyps, tiny living organisms, began building limestone skeletons on submerged continental shelves. Over time, these skeletons accumulated layer upon layer, forming vast underwater mountains made of calcium carbonate. Each generation of coral built upon the ruins of the last, creating a living structure that continues to grow and die, rebuild and evolve. Geologically speaking, the reef is a dynamic monument to time. Sea levels have risen and fallen repeatedly since the last ice age, exposing and submerging the reef multiple times. When the oceans retreated, large sections of coral died, only to be recolonized when the waters returned. Even today, parts of the reef rise on the remains of ancient coral platforms that date back hundreds of thousands of years. Beneath the colourful surface lies limestone formed from countless marine organisms, compacted fossils of microscopic life that once thrived in warm seas. In essence, the Great Barrier Reef is both alive and fossilised, ancient and modern at once. Yet this living geological marvel faces its greatest test. Rising ocean temperatures and acidification threaten to bleach and dissolve the corals that sustain it. But even as some sections fade, the reef's geological heart endures, a testament to Earth's power to create and recreate life from stone. The Great Barrier Reef reminds us that geology isn't only about what's buried underground. Sometimes it's alive, breathing, and still growing beneath the waves. Fact 62. The Grand Canyon. 2 billion years of history. The Grand Canyon is not just a chasm, it's a timeline carved into stone. Stretching for nearly 500 kilometers across Arizona, this vast gorge exposes a staggering 2 billion years of Earth's geological past, stacked layer upon layer like pages in a book written by time itself. At its base lie the Vishnu schist rocks, ancient metamorphic formations forged deep within Earth's crust almost 2 billion years ago. These dark, folded rocks were once seafloor sediments and volcanic material that were buried, compressed, and reborn under unimaginable heat and pressure. Above them rest younger layers, sandstones, limestones, and shales, each representing different environments, shallow seas, coastal plains, and deserts that once blanketed this land long before humans existed. The Colorado River, slicing through this history, began carving the canyon about 6 million years ago. It's an artist of erosion, wielding water and sediment as its chisels. Rain, snowmelt, and time did the rest, deepening and widening the gorge until it became the vast natural cathedral we see today. Every curve and cliff tells a story of ancient climates, vanished worlds, and the relentless power of moving water. Standing on the rim, you're not merely looking at rocks, you're staring into deep time. Each layer beneath your feet represents millions of years of life, extinction, and rebirth. The Grand Canyon isn't static, it's still changing, as weathering and erosion continue to reshape its cliffs. Few places on Earth offer such a humbling view of our planet's age. The Grand Canyon is both a monument and a memory, the Earth remembering itself in stone. Fact 63. Yellowstone supervolcano. Beneath the forest's geysers and wildlife of Yellowstone National Park lies one of the most powerful forces on Earth, a supervolcano so vast it could alter the planet's climate if it erupted again. Yellowstone's story began 16 million years ago, when a massive hotspot of molten rock rose from deep within the mantle. As the North American plate drifted slowly westward over this hotspot, a chain of ancient calderas formed, scars left by past super eruptions. The Yellowstone caldera, the youngest and most famous, exploded about 640,000 years ago, releasing over 1,000 cubic kilometers of ash and rock into the atmosphere. The eruption reshaped the landscape, leaving behind a caldera more than 70 kilometers wide. Today, the ground beneath Yellowstone still breathes. Scientists record constant tremors, rising heat, and shifting ground, all signs of an enormous magma chamber still simmering below. Geysers like Old Faithful are surface expressions of this deep energy, shooting boiling water skyward as pressure builds and releases in rhythmic bursts. Though scientists don't predict an imminent eruption, the Yellowstone supervolcano serves as a reminder that Earth's surface is only a thin skin over powerful geological forces. It's a natural laboratory, helping geologists understand volcanic systems, magma movement, and how life survives in such extreme conditions. Beneath its beauty lies both danger and wonder. Yellowstone is a masterpiece painted by fire. Fact 64. The Atacama Desert, a geologist's time capsule. The Atacama Desert in northern Chile is often called the driest place on Earth. Some regions haven't seen measurable rainfall in centuries. Yet for geologists, this barren landscape is one of the most valuable time capsules on the planet. The Atacama lies in a rain shadow between the Andes Mountains to the east and the coastal range to the west. Cold ocean currents cool the air, preventing it from holding moisture. As a result, erosion is minimal, meaning rocks, sediments, and even ancient riverbeds remain astonishingly preserved. The desert soil is rich in nitrates, salts, and minerals deposited over millions of years by wind and rare bursts of water. These conditions are so unique that NASA has used parts of the Atacama to test Mars rovers, because its landscape so closely resembles that of the Red Planet. Beneath its cracked crust, the Atacama preserves fossils, mineral veins, and even traces of early mining civilizations that once extracted copper and saltpeter. Each layer of sand and stone holds a geological record untouched by time. For scientists, the Atacama Desert is not lifeless. It's timeless. It tells stories of vanished rivers, shifting climates, and the endurance of the Earth itself. Fact 65. The African Rift Valley, birthplace of a new ocean. Running from the Red Sea down through eastern Africa, the Great Rift Valley is a scar of creation, a place where a continent is slowly tearing itself apart. It's one of the most dramatic geological features on Earth, and a window into the planet's future. The rift formed as tectonic forces began pulling the African plate apart about 30 million years ago. Magma rising from the mantle pushes upward, cracking the crust and creating a series of deep valleys, volcanoes and lakes. Each year, the rift widens by a few millimeters, almost imperceptible, yet over millions of years it will transform Africa's landscape entirely. Volcanoes like Mount Kilimanjaro and Mount Kenya were born from this process, rising from the molten rift zones. Massive lakes such as Tanganyika and Malawi occupy the lowest points, where the crust has already thinned. Over millions more years, scientists believe the eastern part of Africa will split away from the rest of the continent, forming a new ocean. The African Rift Valley is geology in motion, an open wound where the Earth is creating something entirely new. Standing along its edges, one can literally witness the birth of a future ocean basin. It's a breathtaking reminder that our planet is not finished. It's still shaping itself, one fracture at a time. Fact 66. Iceland, where fire meets. Iceland is one of the few places on Earth where you can stand between two continents, quite literally. The island sits atop the mid-Atlantic ridge, where the North American and Eurasian tectonic plates pull apart, creating a landscape sculpted by both fire and ice. Everywhere you look, the planet's inner workings are exposed. Volcanoes rise from the snow, geysers erupt in rhythmic bursts, and lava fields stretch for kilometers across the tundra. Glaciers cover much of the island, yet beneath them lie rivers of molten rock, a striking balance between destruction and creation. Iceland exists because of this tension. As magma wells up through the rift, it forms new crust, making Iceland one of the youngest landmasses on the planet. The island grows a little larger with each eruption, and its dramatic scenery tells a story written in both basalt and ice. When the Eyjafjallajökull volcano erupted in 2010, ash clouds shut down air traffic across Europe. But for geologists, it was a living lesson in how Earth renews itself. The same forces that once shaped continents now continue their quiet, relentless work beneath Iceland's surface. Here, the ground breathes, steams and glows, a place where fire and ice coexist, revealing how fragile and powerful our planet truly is. Fact 67. The Himalayas, where mountains still rise. The Himalayas are the highest mountains on Earth, but they're not ancient giants. In geological time, they're newborns, still growing even today. Around 50 million years ago, the Indian subcontinent, once an island drifting north, collided with Asia. The impact was colossal, compressing rock layers and thrusting them upward to form the vast mountain range that now spans 5 countries. Mount Everest, the tallest peak, is still rising by about 5 millimeters each year. The Himalayas are a living experiment in plate tectonics. Their rocks tell stories of ancient oceans, with marine fossils found at the summit of Everest, remnants of the Tethys Sea that once lay between India and Asia. These fossils prove that what is now the roof of the world was once the ocean floor. But the mountain's beauty hides danger. The same tectonic pressures that built them also make the region prone to devastating earthquakes. Beneath the snowy peaks, Earth's crust bends, breaks, and heaves as the collision continues. The Himalayas remind us that even the tallest, most solid-looking places are in motion, shaped by forces far greater than time or weather. They are the Earth's slow-motion explosion, frozen mid-creation. Fact 68. Meteor crater. Earth's scar from the sky. In the desert of northern Arizona lies a hole nearly a kilometre wide, Meteor Crater, one of the best preserved impact sites on Earth. About 50,000 years ago, a nickel-iron meteorite travelling at nearly 70,000 kilometers per hour slammed into the ground. The explosion released more energy than 20 atomic bombs, vaporizing the meteor and carving a massive depression into the plain. For centuries, local indigenous peoples told stories of the site's fiery origin. In the early 20th century, scientists finally confirmed it as an impact crater, one of the first on Earth to be recognized as such. Today, its steep walls and uplifted rim reveal the raw mechanics of an impact that shook the planet's crust. Meteor Crater serves as a reminder that space is not distant. It reaches down to touch Earth from time to time, leaving marks that endure for millennia. Standing at its edge, you can almost feel the echo of that cosmic collision, a moment when the universe quite literally fell to Earth. Fact 69. The Pacific Ring of Fire encircling the vast Pacific Ocean is a belt of volcanoes and earthquakes known as the Ring of Fire. It's the most seismically active region on Earth, a fiery necklace of subduction zones where tectonic plates dive beneath one another. From Japan to Indonesia, Alaska to Chile, the Ring of Fire stretches for more than 40,000 kilometers. Around 75% of the world's volcanoes are found here, along with the majority of its most powerful earthquakes. The reason lies in plate tectonics. As oceanic plates sink into the mantle, they melt and generate magma, which rises to form volcanoes like Mount Fuji, Krakatoa, and Mount St. Helens. The same pressure builds faults that occasionally release their energy in devastating quakes and tsunamis. Life in the Ring of Fire is a balance between danger and renewal. The eruptions that destroy also create, forming fertile soils and even new islands. In this cycle of destruction and rebirth, the Pacific Rim stands as the planet's heartbeat, pulsing with geologic power. To live along the Ring of Fire is to live in rhythm with the Earth itself, unpredictable, beautiful, and alive. Fact 70. The Enduring Planet. A world, still in motion, after 4.5 billion years. Earth is still restless. Its crust shifts, its volcanoes breathe, and its oceans carve new paths through stone. From the oldest fossils to the youngest lava flow, every piece of the planet tells the same truth. Creation never stopped. Mountains rise and erode, continents drift and collide, ice advances and retreats. What seems permanent to us, a valley, a desert, a sea, is only temporary in the eyes of time. Even now, deep beneath our feet, molten rock moves like a slow tide, reshaping the surface above. Earth's outer shell is cracked but connected, a living mosaic of moving plates that carry continents like rafts across a fiery sea. We are witnesses to an unfinished story, one that began before life existed and will continue long after us. Every rock, every fossil, every earthquake is a line in that story. The Earth endures, not as a static world, but as a masterpiece forever being rewritten. Fact 71. The rock-water connection. If rock is the skeleton of the Earth, then water is its lifeblood, moving, shaping, and renewing the very bones of the planet. Together, they form a partnership that never ends, one that defines landscapes and sustains life itself. Rain begins the journey. It falls through the sky, absorbs gases and particles, and seeps into the ground. As it meets the surface, it searches for weaknesses, tiny cracks in rock, pores between grains of sand. With patience, it begins to work, dissolving minerals, widening fractures, and transporting sediments far from where they began. Rivers carve valleys and canyons, waves grind cliffs into beaches. Even underground, water keeps moving, invisible but relentless. In those dark depths, groundwater circulates through fractures and pores, heated by the warmth of Earth's interior. Along the way, it carries dissolved minerals, which can later crystallize into veins of quartz, gold, copper, or other ores. Some of the planet's most valuable resources began as minerals carried by water through ancient stone. When fire meets water, the results can be spectacular. Volcanic rock suddenly cooled by seawater can shatter violently, sending steam and ash high into the air. Entire islands have formed from such encounters, and others have vanished just as quickly. Every drop of water, from the smallest raindrop to the deepest ocean current, participates in reshaping the planet's skin. Mountains crumble, sediments settle, and new rocks form in cycles that have no end. The story of geology is, in many ways, the story of water's quiet, tireless artistry, a force that never sleeps, yet never rushes. Fact 72. Groundwater and aquifers. Hidden beneath the surface lies an unseen world. Vast reservoirs of water stored within layers of rock, soil, and sediment known as aquifers. Though invisible, these underground systems sustain entire regions, feeding rivers, crops, and cities. The journey of groundwater begins with a simple act: rainfall. As rain and melting snow soak into the ground, they trickle through the spaces between grains of sand, pebbles, and fractures in bedrock. Over years, decades, or even centuries, this slow descent fills deep natural reservoirs. Some, like the immense Ogallala Aquifer stretching across the heart of North America, contain water that first fell as rain during the last ice age. Aquifers differ in size, depth, and character. Shallow ones refill quickly, while deep, confined aquifers may take thousands of years to recharge. The water moves slowly, filtered naturally by rock layers that remove impurities. This filtering process is what gives groundwater its remarkable clarity and purity. Yet even this hidden resource can be fragile. When humans pump water faster than nature replaces it, the pressure drops. Wells dry, springs fade, and the land above can sink, a process known as subsidence. Entire regions have lowered by meters due to overuse. Groundwater is not just a resource, it is a balance, a partnership between water, rock, and time. Protecting it means respecting the rhythms of the planet beneath us. Every drop that moves underground tells a story of patience, gravity, and the slow, steady pulse of the Earth itself. Fact 73. How caves form in limestone caves begin not with explosions or earthquakes, but with something almost invisible, a drop of rain. As it falls through the sky, it collects carbon dioxide from the air and soil, forming a weak acid. When that droplet touches limestone, a rock rich in calcium carbonate, a subtle reaction begins. One molecule at a time, the rock dissolves. Over thousands or even millions of years, tiny cracks widen into tunnels. Tunnels merge into chambers, and whole cave systems take shape beneath the surface. Inside, the process continues as dripping water leaves behind traces of the minerals it once carried. From these drips grow stalactites hanging like stone icicles and stalagmites rising from the floor, both formed at a rate of only a few centimeters per century. What results is an underground masterpiece of nature's patience. Vast halls glittering with mineral formations, silent rivers flowing through darkness, and walls sculpted by the chemistry of time. Caves also preserve history. Ancient bones, tools, and even artworks have been found within them, protected for tens of thousands of years by the stable underground climate. Each chamber becomes a time capsule, storing both geological and human stories. In the end, caves are evidence of transformation, how the simplest forces, water and stone, can build worlds of mystery. They remind us that change does not always roar. Sometimes it drips. Fact 74. The power of erosion and sediment transport. Erosion is one of the planet's great sculptors, a slow, steady hand that reshapes everything it touches. It works not through sudden force, but through persistence, carrying mountains down to the sea one grain of sand at a time. Rivers are its greatest agents. They slice through valleys, lift sediments from their beds, and transport them for hundreds or even thousands of kilometers before releasing them into deltas and oceans. Wind joins in, sweeping across deserts, carving dunes and polishing rocks. Ice, in the form of glaciers, grinds mountains flat as it creeps forward over centuries. Even waves contribute, pounding coasts and reclaiming land with every tide. A single storm can move more sediment than years of calm weather. Floods, landslides, and glacial melts accelerate the process, redrawing landscapes in moments. Yet erosion is not merely destruction, it is renewal. The material carried away becomes new ground elsewhere, building fertile plains, beaches, and river deltas rich with nutrients. Over time, erosion and sediment transport drive the continuous recycling of Earth's surface. Mountains rise and fall, valleys deepen, and continents evolve. It's the natural pulse of a living planet, constant change powered by wind, water, and gravity. Every landscape from canyon to coastline is shaped by erosion's quiet persistence. It reminds us that the world is never still. Even the strongest rock is destined to travel. Fact 75. How soil is formed from rocks. Soil may seem ordinary, but it is one of Earth's greatest achievements, the boundary between stone and life. It forms where rock, air, water and organisms meet, creating the thin, fragile skin that sustains everything living on land. The process begins with weathering. Rainwater seeps into cracks and dissolves minerals. Temperature changes cause rock to expand and contract, breaking it apart. Roots dig into crevices, splitting the surface even further. Slowly solid stone becomes fragments, then dust. But it takes more than broken rock to make soil. As plants and animals live and die, their remains mix with these mineral grains. Microorganisms break the organic matter down, enriching it with carbon and nutrients. Layer by layer, the dead feed the living, and the living create the foundation for future life. Different types of rock yield different soils. Granite produces coarse, sandy soil that drains easily but holds little water. Basalt creates rich, dark soil full of minerals. Limestone produces alkaline earth, often fertile for crops. It can take centuries to form a few centimetres of healthy soil, yet careless erosion or overuse can wash it away in a single storm. That makes soil both ancient and fragile, a product of patience and balance. Every handful of earth tells a story written over millennia, of rock worn down, life renewed, and the planet's endless cycle of transformation continuing just beneath our feet. Fact 76. Landslides. Gravity in action. Gravity never rests. It holds mountains in place, yet it also pulls them apart. When the balance between stability and motion tips, the result is one of nature's most dramatic forces, a landslide. Landslides happen when rock, soil, or debris on a slope suddenly gives way. Heavy rainfall can saturate the ground, reducing friction. Earthquakes shake loose already weakened hillsides. Human activity, deforestation, mining, or cutting into slopes for roads can push the balance even further. Once the slope fails, gravity takes command. Within seconds, entire hillsides can move, rushing downhill with the power of a train, reshaping everything in their path. Some landslides are small, moving only a few meters of earth. Others are colossal, shifting millions of tons of rock and soil. In prehistoric times, whole mountains collapsed, leaving scars still visible today. Vast amphitheatres carved into the landscape. Even underwater, landslides occur, generating tsunamis capable of travelling across oceans. But landslides are not only forces of destruction. Over geological time, they build new landforms, blocking rivers to form lakes, filling valleys with fertile sediment, and carving natural terraces. They are one of the ways the planet renews itself, constantly redistributing weight and matter. Landslides remind us that the Earth's surface, though it seems still, is always in motion. Gravity is both sculptor and judge, eternally balancing creation with collapse. Fact 77. The role of weathering in shaping landscapes. Before erosion carries rocks away, another process must first prepare them. Weathering, the quiet breakdown of stone that begins every landscape's transformation. Weathering takes many forms. Mechanical weathering is the work of physical forces. Freezing water expands in cracks, breaking rock apart. Windblown sand scours cliffs smooth. Roots wedge into crevices and pry stones apart. Then there's chemical weathering, where rainwater, slightly acidic from carbon dioxide, reacts with minerals. It dissolves some, alters others, and turns solid rock into softer materials like clay. Even biological weathering plays its part. Bacteria and lichens slowly digest minerals, changing the rock from within. Together, these forces weaken even the toughest mountain ranges. Over millions of years, sharp peaks soften into rolling hills, and exposed cliffs crumble into soil. The process is slow, almost invisible, yet unstoppable. Weathering shapes the colours of landscapes too. Iron-rich rocks rust red in the open air, while copper minerals turn green. Caves, arches, and strange rock pillars all owe their beauty to how differently layers of rock resist weathering's patient attack. Without weathering, there would be no soil, no sediment, no raw material for rivers and glaciers to move. It is the first act in the drama of erosion, the opening line in Earth's endless rewriting of itself. Fact 78. Floodplains and river deltas. Rivers are more than flowing water, they are sculptors of the land. Nowhere is that clearer than in the creation of floodplains and river deltas, the two great gifts of sediment and renewal. A floodplain forms when a river leaves its channel during floods, spreading water and sediment across the valley floor. When the waters retreat, they leave behind a layer of rich silt and clay. Over time, repeated flooding builds broad, flat lands beside the river, perfect for life. The world's earliest civilizations, along the Nile, Tigris, Euphrates, Indus, and Yellow rivers, all rose from floodplains, their fertility renewed each season by the river's rhythm. Farther downstream, at the meeting of river and sea, the flow slows. Sediments drop out, forming deltas, vast fans of branching channels and wetlands. The Mississippi, the Amazon, and the Ganges-Brahmaputra deltas are among the planet's most dynamic ecosystems, where fresh and salt water mix in a delicate balance. Yet floodplains and deltas are not permanent. They shift and evolve. Rivers change course, building new channels and abandoning old ones. Deltas sink as sediments compact, even as new layers rise from above. It's a cycle of loss and renewal that never stops. Though floods can destroy, they also create. They are the river's way of breathing, a reminder that what seems like chaos is often the planet's way of restoring balance. Fact 79. The science of quick clay. At first glance, quick clay looks ordinary, a firm grey soil found in cold, northern regions. But beneath its calm appearance lies a secret. Disturb it, and it can suddenly turn to liquid, unleashing catastrophic landslides in an instant. Quick clay was born thousands of years ago, when glaciers melted and seas covered much of what is now land in Scandinavia, Canada, and Alaska. Fine clay particles settled in salt water, and those salts helped hold the structure together. When the sea retreated and rainwater began to wash through the clay, the salts dissolved, leaving behind a fragile house of cards structure. As long as it remains undisturbed, quick clay stays solid. But when shaken by an earthquake, heavy rain, or construction, its internal bonds collapse. The clay liquefies, flowing like water and carrying everything above it, buildings, forests, even entire hillsides, down in seconds. The Risa landslide in Norway in 1978 showed this power dramatically. A quiet farmland suddenly transformed into a churning lake of mud that swallowed over a square kilometre of land. Quick clay is a humbling reminder that even the most stable ground can hide fragile secrets. In geology, as in life, appearances can deceive, and strength is sometimes only temporary. Fact 80. Tides, waves, and coastal geology. Where land meets sea, the earth never sleeps. The coastline is a battlefield and a dance floor, shaped by tides that rise and fall, and waves that carve and create in an endless rhythm. Tides, driven by the gravitational pull of the moon and the sun, move billions of tons of water twice each day. This constant motion sculpts estuaries, mudflats, and tidal marshes, ecosystems that nurture life and buffer storms. Meanwhile, waves strike the shore with unceasing energy. Over time, they grind cliffs into pebbles and pebbles into sand. They carve arches, stacks, and caves into coastal rock, revealing the layers of time written within. Where currents slow, those same sediments settle, building beaches and sandbars. It's a delicate balance. Creation and destruction in harmony. Storms can redraw coastlines overnight, while gentle waves take centuries to shape a single cove. Human activity, from seawalls to harbours, alters these patterns, sometimes protecting land, sometimes hastening erosion. The coast is a living boundary, a line that shifts with every tide and storm. Standing by the sea, you're watching geology in motion, the heartbeat of a planet that never stops changing. Fact 81. How seismographs measure earthquakes. Imagine standing perfectly still, while the ground beneath you starts to tremble. That's what a seismograph feels every time Earth decides to move. A seismograph is basically a sensitive pen that writes down the planet's shivers. The idea is simple. If the ground moves, a weight suspended on a spring stays still for a split second, and that motion difference gets recorded as a wavy line. Those waves are called seismograms, and they tell scientists everything about how powerful and deep an earthquake was. Early versions were surprisingly clever. Even ancient inventors built earthquake sensors with swinging pendulums or dragon-head jars that dropped metal balls when the earth shook. But the modern seismograph, developed in the 19th century, turned this curiosity into science. Today, digital sensors record ground motion thousands of times per second, allowing experts to detect quakes so faint that people never feel them. What's even more fascinating is that seismographs don't just pick up earthquakes, they can sense landslides, volcanic activity, explosions, even ocean waves hitting the shore. In a way, they're like stethoscopes pressed to the chest of the planet, listening to its heartbeat day and night. Fact 82. The Richter and moment magnitude scales. You've probably heard someone say, it was a 7.0 on the Richter scale. But what does that number really mean? Back in 1935, Charles F. Richter came up with a way to compare earthquakes by measuring the amplitude, the height, of seismic waves on a seismograph. The scale was logarithmic, meaning each whole number jump represented 10 times stronger shaking. But as science advanced, researchers realized the Richter scale had limits. It worked well for California quakes, but not for massive ones around the world. So came the moment magnitude scale, a more accurate system that measures the total energy released. It considers how much the ground slipped and how large the fault area was. Today, when you hear about an earthquake's magnitude, it's probably using the moment scale, though people still say Richter out of habit. The key takeaway? Each step up the scale releases about 30 times more energy. So a magnitude 8 quake isn't just a little stronger than a 7, it's a monster by comparison. Fact 83. Predicting earthquakes. Science or guesswork? Can we really predict when the ground will shake? It's one of geology's most haunting questions. Scientists can estimate where earthquakes are likely to happen, but when, that's still out of reach. Faults can stay quiet for centuries and then rupture suddenly, giving almost no warning. Researchers have tried everything, from tracking tiny tremors to measuring gas leaks, animal behavior, even changes in magnetic fields. But so far, no pattern reliably predicts the next big quake. What we do have are early warning systems. When seismic waves start, sensors near the epicenter send alerts to cities seconds before the shaking arrives. Those few seconds can save lives, enough time to stop trains, shut gas lines, or take cover. So no, we can't predict earthquakes yet. But we're learning their habits. Each tremor adds another clue to the puzzle of how our restless planet releases its energy. Fact 84. The deadliest earthquakes in history. Some earthquakes do more than shake the ground, they reshape history. The year 1650, in China, saw one of the deadliest quakes ever recorded, killing hundreds of thousands. In 1976, Tangshan, China was struck again, leaving devastation across the region, and in 2010, Haiti's quake turned cities to rubble in moments. But it's not just magnitude that makes an earthquake deadly, it's location, population, and building strength. A moderate quake in a crowded city with weak infrastructure can be far worse than a giant one deep under the ocean. After each disaster, engineers and geologists study the damage to learn how to build safer structures. In a strange way, every tragedy teaches us resilience. From ancient temples that survived centuries of tremors to modern skyscrapers swaying safely in the wind, humanity has slowly learned to live with the planet's restless energy. Fact 85. Fracking and induced seismicity. Not all earthquakes come from nature. Some are our own doing. Induced seismicity happens when human activities change underground pressure, like injecting fluids during oil and gas extraction, also known as fracking. The process cracks deep rock layers to release trapped fuel, but it can also lubricate old faults, causing them to slip. Most of these quakes are small, barely noticeable, but a few have reached magnitudes that shook nearby towns. Scientists now monitor these regions closely, mapping injection sites and tracking tremors in real time. Regulations in many countries require operators to pause or stop injections if seismic activity rises too high. It's a reminder that Earth's crust is a delicate balance of pressure and resistance. Even small changes can ripple through miles of rock. The more we learn about induced quakes, the better we can manage energy production without stirring the sleeping faults beneath our feet. Fact 86. Mining and the geology of resources. Every phone, car, and building you see started as part of the Earth. Mining is how we bring those buried materials to light. It's easy to think of it as just digging for metal, but in truth, it's geology in action. The search for clues left by millions of years of natural processes. Geologists hunt for ore deposits, places where metals like copper, gold, and iron have gathered in high concentrations. Some formed from ancient magma that cooled slowly underground, others from hot fluids that once moved through cracks, leaving minerals behind. Even coal and salt have their own geological stories, born from ancient swamps or evaporated seas. Mining has always shaped human civilization. Early people used stone tools, then bronze, then iron. Each new discovery changed society's direction. But mining also comes with challenges: environmental scars, water pollution, and displaced communities. That's why modern geologists focus not only on finding resources, but also on mining responsibly. Today, satellite mapping and 3D geological models make exploration more precise than ever. Instead of guessing, scientists can see beneath the surface, tracking mineral patterns with magnetic and seismic tools. The goal is simple: take only what's needed, disturb as little as possible, and leave the land ready to heal. Fact 87. How geology powers the energy industry. The lights in your room, the gas in your car, even the wind turbines on a hill, all connect back to geology. Every form of energy starts with Earth's natural materials. Fossil fuels like coal, oil, and gas were born from ancient organic matter, buried and compressed over millions of years. Without an understanding of rock layers, traps, and sedimentary basins, we'd never have found them. Even renewable energy depends on geology. Geothermal plants tap into heat from deep underground. Hydro dams rely on rock stability. Wind farms need strong flat terrain, and the minerals for solar panels and batteries come from specific geological formations. In a way, geology is the unseen foundation of the modern world. Every pipeline, power plant, and energy source begins with someone reading the language of the rocks. And as we shift toward cleaner power, geologists are again at the forefront, searching for lithium, cobalt, and rare earths that will fuel the next generation of technology. So the next time you flick on a light switch, remember that energy's story began long before humans ever walked the planet, deep within the rocks themselves. Fact 88. Geothermal energy from beneath our feet. If you've ever seen steam rising from a hot spring or a geyser bursting skyward, you've witnessed geothermal energy in its raw form. It's the heat left over from Earth's fiery birth, still bubbling below the surface, still powerful after billions of years. Geothermal energy plants tap into this heat. Wells are drilled deep into the ground to reach hot water and steam reservoirs. That steam spins turbines to generate electricity, clean, steady, and renewable. Unlike sunlight or wind, geothermal energy doesn't stop at night or calm on quiet days. Some of the best-known geothermal areas lie along plate boundaries, where magma sits close to the surface, places like Iceland, New Zealand, and parts of California. But even in cooler regions, new drilling technologies are unlocking hidden potential deep underground. The beauty of geothermal power is its simplicity. It's Earth's warmth, reused. No smoke, no fuel, just the steady heartbeat of the planet itself. As the world searches for cleaner energy, this ancient heat might just light the way forward. Fact 89. Ground subsidence and urban geology. Cities may seem solid, but the ground beneath them can be surprisingly fragile. Ground subsidence happens when the land slowly sinks, often caused by human activity like pumping groundwater, mining, or removing oil and gas from underground. As the material below compacts, the surface drops. In some cities, the change is dramatic. Parts of Mexico City have sunk over 9 meters in the last century. Similar problems appear in Jakarta, Venice, and regions in California's Central Valley. The consequences can be serious. Cracked roads, tilted buildings, flooded neighbourhoods. Urban geologists study these problems to understand how rock, soil and human activity interact. They use radar satellites, laser scans and ground sensors to track even tiny changes in elevation. The goal is prevention, balancing water extraction, reinforcing foundations, and planning smarter. Beneath every city lies a geological story, old riverbeds, buried valleys, or ancient sediments that behave differently under pressure. Understanding that hidden layer is key to keeping our cities standing tall for generations to come. Fact 90. Climate change. Written in stone rocks, remember what we forget. Every layer of sediment, every coral reef, every fossilized pollen grain tells a story of Earth's changing climate. By studying these clues, geologists can read the diary of our planet, written over millions of years. Ice cores from Antarctica show patterns of past temperatures and greenhouse gases. Fossilized tree rings reveal droughts and rainy years. Ancient lake beds preserve dust from desert winds. Together, these records prove that Earth's climate has always changed, sometimes slowly, sometimes in sudden leaps. But what's different now is the speed. In just a few centuries, atmospheric changes that once took tens of thousands of years are happening before our eyes. Geology shows us both the warning and the hope. The planet can adapt, but it always responds. Understanding the rock record reminds us that every action leaves a mark. The stones beneath our feet aren't just relics of the past. They're quiet witnesses, recording the story we're still writing today. Fact 91. The Great Barrier Reef. A living geological structure. Stretching along Australia's northeastern coast, the Great Barrier Reef is often called the largest living structure on Earth. But beneath its colourful surface lies a geological story millions of years in the making. The reef didn't appear overnight. It slowly built itself on the bones of the older reefs, rising and falling with ancient sea levels. Coral polyps, tiny animals that create calcium carbonate skeletons, are the quiet architects here. Over time, their skeletons accumulate and harden, forming massive limestone ridges. When sea levels dropped, parts of the reef died. When they rose again, new corals grew on top. Layer after layer, the reef became both alive and fossilized. A structure that's part biological, part geological. Today the reef still records every shift in sea level, temperature and chemistry. Scientists studying its cores can read the ocean's climate history like pages in a book. And though it faces modern threats, it remains a living link between the deep past and the uncertain future. A reminder that even the most vibrant ecosystems rest on the quiet foundation of stone. Fact 92. The Grand Canyon, 2 billion years of history. Stand at the edge of the Grand Canyon, and you're looking into time itself. Each layer of rock exposed along those cliffs tells a chapter of the Earth's story. From ancient seas and swamps to volcanic eruptions and mountain-building events. Some of the oldest rocks at the bottom date back nearly 2 billion years. What's astonishing is that the canyon itself is relatively young, carved only about 5 or 6 million years ago by the Colorado River. That river, armed with patience and sediment, sliced through layers of sandstone, shale and limestone like a slow-moving saw. Every drop of water carried away grains of the past. Geologists come here not just for the view, but for the record. The Grand Canyon captures nearly half of Earth's known geological timeline in a single, breathtaking panorama. It's a place where you can literally touch the ancient stone that was once mud on a seafloor, now standing high in desert air. Fact 93. Yellowstone supervolcano. Beneath the peaceful forests and steaming geysers of Yellowstone lies one of Earth's most powerful volcanic systems, a supervolcano that has erupted 3 times in the last 2 million years. Each eruption was thousands of times larger than Mount St. Helens, spreading ash across continents. But don't picture a mountain waiting to explode. Yellowstone is more like a vast underground cauldron, a magma chamber that occasionally releases pressure through geysers, hot springs and fumaroles. These features are the surface's whisper of the enormous heat below. Scientists constantly monitor Yellowstone using GPS, seismographs and gas sensors. The ground rises and falls slightly as magma shifts, but there's no sign of an imminent eruption. Still, the place commands respect, a reminder that our calm landscapes can hide unimaginable power beneath. Yellowstone is not just a wonder of nature, it's a window into Earth's fiery heart. Every burst of steam is a message from below, a quiet echo of the planet's restless energy. Fact 94. The Atacama Desert. A geologist's time capsule. In northern Chile lies the Atacama Desert, one of the driest places on Earth. Some parts haven't seen measurable rainfall for centuries. For geologists, this arid silence is priceless, because here, time hardly moves. Rocks and landscapes remain preserved as if frozen in place. The Atacama holds salt flats, copper mines, and ancient volcanic fields, but also something more subtle, the record of how planets age. Its dry conditions resemble those on Mars, which is why NASA tested rovers here before sending them into space. Even bacteria struggle to survive, leaving behind a terrain shaped almost entirely by wind and sunlight. Beneath the surface, minerals tell of shifting climates and ancient waters long vanished. Every grain of sand holds a story of evaporation and endurance. The Atacama may look lifeless, but to geologists it's alive with memory. A perfect time capsule of Earth's most extreme beauty. Fact 95. The African Rift Valley. Birthplace of a new ocean. Imagine standing in a place where a continent is splitting apart. That's what's happening in East Africa right now. The African Rift Valley stretches thousands of kilometers from the Red Sea down through Mozambique, a deep scar where tectonic forces are slowly tearing the continent in two. Over millions of years, magma has pushed upward, cracking and thinning the crust. Volcanoes, fault lines, and long valleys mark the separation. Eventually the land between these rifts will sink and fill with seawater, forming a brand new ocean. It's a rare opportunity for scientists and to witness continental breakup in real time. The rift also created fertile soils, vast lakes, and even environments where early humans once walked. Every mountain and crater here is evidence that Earth never stops evolving. It just moves at a pace too slow for our eyes to see. Fact 96. Iceland, where two continents meet. Few places on Earth show plate tectonics as clearly as Iceland. The island literally straddles two continents, the North American and Eurasian plates, and they're pulling apart by a few centimeters every year. You can even walk between them in Thingvellir National Park. This slow separation allows magma from below to rise and create new crust, which explains why Iceland is filled with volcanoes, geysers, and hot springs. It's like watching the planet rebuild itself piece by piece. But there's something poetic about it too. Iceland's fire and ice coexist beautifully. Glaciers sit above magma, rivers cut through lava fields, and the landscape keeps reinventing itself. Every eruption, every new layer of rock is a reminder that Earth's story is still being written, right here, at the meeting of worlds. Fact 97. The deep ocean trenches. Far below the waves, where sunlight never reaches, lie the deepest scars on Earth's crust, the ocean trenches. The Mariana Trench, for instance, plunges nearly 11 kilometers deep. These trenches mark where one tectonic plate slides beneath another in a process called subduction. It's a place of crushing pressure and darkness, but it's also full of life and geological activity. Mud volcanoes, methane seeps, and deep-sea quakes all occur here. As the descending plate sinks, it melts and fuels volcanic arcs like Japan and the Andes. What makes these trenches fascinating is how little we know about them. Only a handful of people have ever descended to their depths. Each exploration reveals new species, new minerals, and new mysteries. Proof that even in the 21st century, parts of Earth remain almost completely unexplored. Fact 98. Meteor crater and impact geology. Long before people existed, a rock from space slammed into what is now Arizona. The explosion released energy equivalent to several atomic bombs, carving out a massive pit, meteor crater. It's one of the best preserved impact sites on Earth, and a key piece of evidence that asteroids have shaped our planet's surface. Impact geology studies these cosmic collisions, not just for their drama, but for their importance. Impacts have melted crust, created minerals found nowhere else, and even influenced evolution by triggering mass extinctions. The Moon's craters are frozen reminders of what Earth once endured more frequently. Standing at Meteor Crater today feels like looking at a paused moment of violence, a single instant written forever in stone. It's a reminder that Earth's history isn't isolated. It's part of a larger cosmic dance, where worlds collide and reshape each other. Fact 99. The future of geology, from Mars to exoplanets. Geology isn't just about Earth anymore. With robotic explorers crawling across Mars and telescopes scanning distant worlds, scientists are now doing interplanetary geology. The rocks on Mars, for example, show ancient riverbeds and volcanoes eerily similar to those on Earth. Even on distant exoplanets, worlds orbiting other stars, scientists use light and chemistry to guess their geological makeup. Could there be continents, oceans, or even plate tectonics elsewhere? The answers might redefine what we know about planets themselves. Geology began as the study of what's beneath our feet, but it's evolving into a cosmic science. Whether it's a desert on Earth or a crater on Mars, the same principles apply: pressure, heat, erosion, and time. The more we look outward, the more we understand where we came from. Fact 100. What rocks tell us about the fate of Earth. Every rock on this planet is part of a cycle, a loop of creation, destruction, and rebirth. The continents drift, collide, and wear down. Oceans open and close. Mountains rise, crumble, and rise again. Geology tells us that Earth is never still and never truly finished. In billions of years, the continents will merge into another supercontinent. Volcanoes will reshape the air. The sun will eventually grow hotter, changing the oceans forever. It's a long, slow story, but rocks already hold its first chapters. When we study geology, we aren't just looking backward. We're glimpsing forward too, learning what might happen when time has its way. Every stone is a message from the past, but also a whisper about the future, that everything changes and nothing ever really ends.